Welcome to the Greenhouse Gases unit. We're going to do a model observation lesson, and for that we first need to find the greenhouse gases base model in the Guts-Star-LogoNova public folder. So here we have the Guts-Star-LogoNova public folder, and I'm just going to navigate to the greenhouse gas model. I happen to know it's this one we want. The other way of finding it is by looking for 22078 is the project ID. And if you have that number, then you're in the right one. So here we are looking at the greenhouse gases base model. Before we start seeing how the model works, let's look at the interface. And up at the top here, we have our information panel. This is a handy way of reading what is happening in this model. So it's quite a detailed description. Now as we go down, we can notice a few different things. Before you start the model, look at the interface itself. And what can you guess the model might represent or test? Look at this data box and this graph for clues. This model is best viewed from the side, but the default view of Spaceland is from above. So the first thing we need to do is adjust this view so that we can see the model more clearly. To do that, we would press Shift Alt click and then drag, and as you can see, I'm clicking those buttons and dragging over the screen, and the world is now going horizontal. So this is how we get a sideways view of the world. You may lose the world the first time you do this. If you do, the green disappears. Just hit Reset Camera, and that'll send it back to that view from above. And then you can try resizing it again. So let's start off with the model by hitting Setup. Now what do you notice? The first thing we see is that a big yellow globe has appeared. So let's hit Forever. Watch what's happening on the interface. Who are the agents? What is the environment? And how do those agents behave? Focus on observations like where solar radiation is beginning and what is happening to it, rather than trying to guess why things are happening as they are. Look closely at the solar radiation when it hits the ground. There are two possible outcomes for that solar radiation. You can do this by zooming in and watching it, and you can zoom back out. Watch the graph and the data box and see if you can figure out what is being measured and what it represents. Now spend a little time thinking about the assumptions in this model. For example, the sun is putting out solar radiation at a constant rate. How does that differ from what we know about solar radiation? Use this assumption to help explain abstraction, that some behaviors might have been left out of the model because they were not necessary to explore the questions it asks about solar radiation, reflection, and absorption. Run the model a few times for about the same length of time. Do you always end up with the same heat in the world? There will be elements of randomness in the model if the result is not always the same. Look closely at the solar radiation hitting the ground. Sometimes it bounces back as a yellow ball, and sometimes as a red ball. That red ball represents infrared radiation, or heat. A certain percentage of the time, we won't know what percentage until we look at the code, the solar radiation is absorbed and then re-emitted as heat. This percentage represents the albedo, or reflectivity of the surface. The more reflective the surface, the less solar radiation becomes heat. Reflect on a question you could test involving the albedo and the amount of heat in the world for an experiment.